Okay, check out the textbook 3D character walk cycle on the left side here. It's generated using standard graph curve smoothing. And yeah, it's mathematically perfect, super smooth, and completely lifeless. Now, look over at Ava Thompson on the right, doing the exact same path. Her motion feels strikingly present, doesn't it? It's tactile. It's deeply biologically grounded. You can literally see the subframe jitter and these nonlinear weight drops right in her silhouette. And here's the kicker. The difference between these two isn't about the raw skill of the artist. It's actually about the software. See, most 3D animation falls flat because standard software defaults want to push your motion into mathematical perfection. And ironically, mathematical perfection is the exact opposite of real life.
And that brings us directly to the dreaded Uncanny Valley. We all know it, right? It's that unsettling, kind of creepy feeling you get when an animation looks almost human, but your brain is screaming that something is fundamentally off. Software inherently craves symmetry. It wants clean interpolation, perfect frame rate division, the whole shebang. But biology is messy. The Ava Effect we just looked at isn't some secret proprietary magic plugin you can just buy. Escaping the Uncanny Valley takes a deliberate, highly technical system to intentionally break that software precision.
So, welcome to this explainer. Today, we're going to completely deconstruct this animation magic trick, secret by secret. We're going under the hood to look at the specific, actionable pipeline mechanics that let animators achieve this insane level of biological realism. Trust me on this, if you're looking to elevate your animation out of the realm of those robotic software defaults, you are in exactly the right place. Let's get right into it.
All right, here is our roadmap for today. First up, we'll explore asymmetric drag. Second, we're looking at silhouette cheating. Third, we'll uncover the noise floor. And finally, we're going to bring all of this together so you can master the Ava effect.
Let's kick things off with secret number 1, asymmetric subframe drag.
So, standard animation tutorials completely condition us to set our keyframes on full, solid frames, right? Frame 10, frame 15, frame 20. But the reality is, actual physical anatomy completely rejects that rigid 24 frames per second grid. In Ava's pipeline, primary motion drives secondary motion through some highly specific offsets. Let's use the eye and head movement as our example here. Step 1 is the lead control. The center of the eye initiates a rotation exactly on frame 0. But watch what happens in step 2. The primary subcontrol, which is the upper skull structure in this case, doesn't actually move at the same time. It drags behind by exactly 1 frame. The upper eyelid actually drags by 1.5 frames. And the jaw? It responds with this tiny micro drop 2 full frames after the neck comes to a rest. Finally, we have step 3, which introduces micro-interruptions. Even during hold poses, the keyframe values are never just static, dead flat lines. They are populated with these tiny 0.2 degrees subframe offsets, and this brilliantly simulates actual muscle twitches and breathing mechanics.
So the absolutely crucial rule you need to remember here, you must offset every single secondary channel by 1 to 3 subframes. Why? Well, because if 2 opposing body parts stop moving on the exact same frame, your animation instantly looks mechanical. It looks dead. It's a dead giveaway that a computer is driving the bus. Staggering those channels forces the motion to resolve organically, just like real muscles absorbing momentum in the real world.
Moving right along, let's look at secret number 2, non-Euclidean silhouette cheating.
Now we're shifting our focus from how we manipulate time over to how we manipulate space. Because while beginners tend to treat 3D rigs like these unbreakable statues, professionals treat meshes more like liquid clay. Seriously, take a look at the perspective workspace view on the left here. The mesh looks completely broken, right? It is aggressively stretched, scaled, and totally distorted. But then look at the right side, the actual shot camera view. That broken geometry creates this powerful, razor-sharp motion blur arc that just looks phenomenal. The workflow here deliberately breaks anatomical topology to serve the final 2D frame. Honestly, it doesn't matter what the character looks like from the side or the top. It literally only matters what the rendering camera sees.
Let's zoom in on a microscopic yet highly impactful detail. 130%. Sounds a bit extreme, doesn't it? Well, during a high-speed reaction shot, Ava's forearm geometry isn't just moved, it is scaled up by exactly 130% and stretched laterally along a single axis. And this is held for just a 1 to 2 frame duration. Why on earth would you do that? To essentially fake a 2-frame motion blur. It bridges fast camera movements in a way that feels incredibly visceral, without relying on standard software motion blur calculations, which, let's be honest, often look kind of weak and smudgy.
There are 3 primary ways we cheat the silhouette to make this happen. First up is smear geometry. Just like that 130% forearm scale we talked about, bones are scaled asynchronously to bridge those really fast movements. Second, we use volume offsets. When Ava squashes down into an anticipation pose, her rig expands sideways unevenly. Now, this blatantly breaks real-world volume preservation rules, but it creates a much stronger, punchier graphic shape on screen. And third, camera relative posing. The rig is distorted strictly relative to the active camera lens. You're completely ignoring how weird or distorted the mesh becomes from literally any off-camera angle.
And that brings us to secret number 3, the noise floor weight system. This one is all about the illusion of gravity. Because honestly, the absolute fastest way to plunge your character right back into the Uncanny Valley is by using a perfectly static idle pose. Notice how a standard idle pose leaves the root or center of mass controllers sitting on completely flat F-curves. The character is completely static. But in real life, standing still isn't actually a passive action. It requires continuous, active muscular micro-adjustments just to fight gravity and stay upright. And that is exactly where the noise floor comes in. Instead of flat lines, we apply this non-periodic, layered, low-frequency wave noise directly to the pitch and roll channels of the core controllers. So even when the character is supposedly just standing there, there's a continuous, subtle shifting happening right beneath the surface. Just look at the sheer microscopic scale of these adjustments. We are tying the character's breathing weight directly to their balance foot. When the lungs expand, the center of mass shifts by just 0.5 centimeters toward the dominant leg. Half a centimeter? It is incredibly subtle, but I really want you to take this away. Biological realism lives entirely in these microscopic margins of the animation curve. It's these tiny, constant battles with gravity that secretly tell our brains the character is actually alive.
Finally, let's wrap this up with Section 4, Mastering the Ava Effect.
We've looked at all these mechanics in isolation, but true mastery really comes from synthesizing them. So here is your final checklist to ensure your work never looks flat or robotic again. Number 1. Implement asymmetric subframe drag. Get off that perfect frame grid and offset your keyframes across secondary channels so that absolutely nothing stops moving at the exact same time. Number 2. Embrace silhouette cheating. Seriously, stop treating your rigs like statues. Distort your geometry, stretch those limbs, and break the topology so you can master the final 2D frame. And number 3. Utilize the noise floor weight system. Never let your core controllers sit flat. Keep gravity active with continuous micro-adjustments even when your character is just standing completely still.
I want to leave you all with this final thought. The Ava Effect isn't magic. It's the technical mastery of breaking software mechanics to serve biological truth. Stop letting your software dictate your timing. You know, it is so easy to just let the computer do the math, to let it smooth out the curve and average out the motion. But life doesn't happen in averages. So the question is, moving forward, are you going to keep letting your software run the show, or are you going to take total, unapologetic control of your keyframes to create something that is truly alive?